Every second of your life, your eyes are flooded with light. Millions of photons stream through the air, bounce off surfaces, and strike the back of your eye. But what you experience isn't a raw feed of reality. It's a carefully constructed illusion, sculpted by your brain. A convincing story that feels solid, stable, and true, but is always edited. Let's begin with the mechanics. Light enters through the cornea, bends through the lens, and lands on the retina, a thin sheet of tissue at the back of the eye. Here, rods and cones wait. Rods are sensitive to light and dark, crucial for night vision. Cones are tuned to color, clustered in the fovea, the center of sharp vision. These cells convert light into electrical signals, which travel along the optic nerve into the brain. But here's the catch. The retina is flat. It contains no depth, no constancy of color, no motion. All of those qualities are invented later by the brain. Your brain doesn't simply record, it interprets, it predicts, it fills in gaps. What you see isn't the world itself, it's the brain's best guess at what the world should be. Take depth. The world feels three-dimensional, but the image on your retina is two-dimensional. To create depth, your brain stitches together cues. Binocular disparity. Each eye sees a slightly different image, and the brain fuses them into depth. Monocular cues. Perspective, shading, relative size. These shortcuts usually work, but illusions reveal the cracks. Consider the Mueller-Lyer illusion. Two lines of equal length, one capped with inward-pointing arrows, the other with outward-pointing arrows. The line with outward arrows looks longer, even though both are identical. Or the Ponzo illusion. Two parallel lines framed by converging rails. The upper line looks longer because the brain interprets the converging rails as depth. And then there's the moon illusion. The moon's angular size is constant, but on the horizon it looks enormous. Our brains misinterpret distance cues, inflating its apparent size. Depth isn't in the eye, it's in the mind. Now consider color. We think of color as a property of objects. A red apple is red, a blue sky is blue. But color isn't fixed. It's a negotiation between light, context, and expectation. Take the checker-shadow illusion. Two squares on a checkerboard, one in shadow, one in light. They are physically identical in shade, yet the one in shadow looks lighter. Why? Because the brain compensates for lighting, adjusting colors to maintain consistency. Edwin Land's Retinex theory showed that color perception depends on comparisons across the visual field, not just raw wavelength. And who can forget the viral dress of 2015? Some saw blue and black, others white and gold. The difference came down to assumptions about lighting. Was the dress in shadow or in bright light? The brain made a choice, and perception followed. Color isn't a property of objects. It's a story told by the brain. Motion, too, is a construction. Specialized cells in the visual cortex exaggerate motion to detect threats. That's why stationary images with repetitive patterns can appear to move. The brain's motion detectors are triggered by contrast and repetition. During rapid eye movements, called saccades, the brain suppresses blur. You don't notice the smear of motion as your eyes dart around. Instead, the brain stitches together a stable scene. Even during blinks, when vision is interrupted, the brain fills in missing frames, maintaining continuity. This is predictive coding. The brain forecasts sensory input and corrects errors before you notice them. You don't see motion as it is, you see motion as your brain expects it to be. Beyond mechanics, perception is shaped by meaning. Gestalt psychology revealed principles of grouping, proximity, similarity, closure, continuity. These rules explain why we see wholes instead of fragments. The Kenesha triangle is a perfect example. Three Pac-Man-like shapes arranged just so, and suddenly you see a triangle that isn't there. The brain invents edges, preferring structure over chaos. Pareidolia takes this further. We see faces in clouds, sockets, or rock formations. fMRI studies show that face recognition areas in the brain activate even for imagined faces. The brain is a storyteller. It prefers meaning over accuracy and narrative over randomness. Why does the brain build illusions? Because survival depends on speed, not accuracy. A predator in the grass must be recognized instantly, even if the details are fuzzy. A cliff edge must look solid, even if shadows distort its shape. Illusions are the price of efficiency. Studies of visual reaction times show humans detect looming threats faster than receding ones, a bias toward survival. We live inside a useful fiction, a world sculpted for action, not for perfect fidelity. This realization has profound implications. In the 19th century, Hermann Helmholtz proposed the idea of unconscious inference, that vision is a process of educated guessing. Modern neuroscience confirms this. Predictive processing models describe the brain as a prediction machine, constantly forecasting sensory input and updating based on error. Artificial intelligence systems, too, hallucinate when faced with ambiguous inputs. Comparing human and AI illusions reveals a shared reliance on contextual assumptions. Philosophically, if perception is constructed, then reality itself is a negotiated story between the world and our nervous system. We do not see the world as it is. We see the world as our brain expects it to be. So, when you look around, remember, you're not seeing reality raw. You're seeing reality sculpted, interpreted, imagined. A grand illusion, convincing, useful, and beautiful. And in that illusion lies both the wonder and fragility of human perception. Thanks for watching, and, as always, stay curious.